Hello, I'm Papia. In this problem, we have this function x squared plus x minus 1. We have to first verify that the intermediate value theorem applies to this function and the interval given to us is 0 to 5. And then if the function satisfies all the hypotheses for intermediate value theorem, we have to find out what is that c so that f of c is equal to 11, because the intermediate value theorem guarantees that there will be a c. Okay, so it's two-phase. Let's start with verifying that intermediate value theorem does apply. So remember how to verify it. There are two things that you have to check. First, check if this function is continuous or not inside this interval between 0 and 5. Well, look at the function. It's x squared plus x minus 1. It's a quadratic. It's a polynomial, right? There is no denominator. There is no radical. So since this is a polynomial, we know it's continuous everywhere, right? So f is a polynomial and therefore it's continuous everywhere, and in particular it is continuous inside this interval. So that first condition checks. Second, we have to find the value of this function at the end points of the interval. So let's see what is f of 0. So plug in 0 for x, you get 0 square plus 0 minus 1. So that is just negative 1. And also find f of 5, because that's the other endpoint. So plug it in the expression again. So we get 5 square plus 5 minus 1. So this is 25 plus 5, that's 30, minus 1 is 29. So we have to verify that the two values at the two endpoints, they are not equal. And that is the case. One of them is negative 1, one of them is 29. Okay, so these two conditions verifies that the function satisfies all the hypotheses so that we can apply the intermediate value theorem to it. Now, remember what the intermediate value theorem says. What is the conclusion? It says if you pick any value between these two, negative 1 and 29, for example, 11 is such a value. If you pick that between these two, then there will always exist at least one x value c, so that when you plug it in the function, you get 11. So we have to figure out what c will give us that value 11. So note that 11 definitely lies between negative 1 and 29. So we can use that value to conclude our conclusion for the intermediate value theorem. So question is, what is the c so that f of c is 11? So it's an equation, right? Plug in f of c, figure out what that is. So go back to our expression for the function and plug in c for x. So the left hand side is just c squared plus c minus 1. Right hand side is 11. So you just have to solve for c. Okay? You can see that this is a quadratic equation, right? So bring everything in the left hand side, set it equal to 0, and then just factor and solve. Okay, so we have c squared plus c. So negative 1 and then minus 11, that will make it negative 12. That is equal to 0. So let's factor. This is negative 12, so you will get, and this is a plus 1. So c plus 4 and c minus 3. Right? 4 times negative 3, that's negative 12. 4c, negative 3c, that's plus c. So this is equal to 0. And then 2 factors will give you 2 values for C. So we will get C equals -4 is one of them, or we have C equals 3. That's another one. So what does that mean? We got 2 different values. That means intermediate value theorem doesn't say that there has to be exactly one value. It can be more than one. And in this case, it is. So you actually have 2 different C that if you plug in the function, you get the output 11. So here are our answers. C can be either -4 or 3 for f of C to be equal to 11. Thank you.